be here at GeoLivre for the presentation of Ageospatial, our startup made in Switzerland. We are very happy to talk to you about what we're developing with GeoForge, which is a web geospatial platform assisted by a geospatial language model. There are a bunch of challenges that we encounter when we talk about geospatial data for authorities or governments, whether they're local, federal, or regional. One of those is that data takes time being analyzed. There's no information on social infrastructure. Usually those data sets are quite expensive, and which means that events such as floods are not usually analyzed, and that the accessibility for experts is low, which means that locals have to rely on non-experts. One of the solutions that we looked into initially also led us to another industry facing the same problems, which is here the insurance firms. And of course, initially we focused on natural disaster scenarios within the public sector, but we soon realized through discussions with two major insurance players that our technology also applies to this sector. We continue collaborating with Swiss universities as they trusted us in a very early stage. One of the challenges for insurances is that there are millions of sites and there's not enough people to inspect them all. Information's overlooked usually. There is difficulty fusing diverse geodata sources, and it's quite hard to get challenges in near real-time data for disaster response. Our work within this involves context and threat analysis for insured industrial and commercial buildings, but further details are restricted due to an ongoing NDA with a major insurance provider. Well, how do we solve those challenges? What we propose is through geospatial AI that is assisted by a generative AI chatbot, where a language model is fine-tuned into a geospatial language model, and natural language is translated into a sequence of geoprocessing operations, which form a solution graph that is ultimately validated by the user. This matters because it gives more accessibility and more control over decisions that is made by AI. We're proposing a web-hosted cloud solutions that also supports scalable infrastructure, increased server-side processing speeds, and the use of latest geospatial data formats and technology, as well as data management systems. This is all done remotely on secured servers in Switzerland, so you don't need it on your computer, but simply access it through your browser. We have our main platform, which is called GeoForge, and it's hosted on the web. It's currently a work in progress, so everything that you're going to see is, of course, subject to change in the coming months. One of the cases we looked into was remote inspections. When you have a place and you want to ask to geocode simply the place and tell you more about what's around that area. You're able to look at buildings, you're able to look at the electric infrastructure, you're able to look at parkings, which represent a risk for some insurance companies. You're able to look at roads, railways, all through a text interface. Then you can also draw an itinerary from the place to the train station and look into satellite imagery, whether it's optical or it's radar. And the second case here is impact assessment. You have a few places of interest, typically power stations, buildings, and such. And here you're able to do some quick intersects using the chat interface to see the affected buildings, lines, etc. We also use radar imagery to get an idea of the water extent during floods. And of course, it's not a perfect world. We do face challenges in terms of data accuracy and hallucinations of models, whether they're geospatial AI models, here we're talking about foundation models, and whether they're generative AI models, we can think about OpenAI's ChatGPT that was used by our team, and also very recently Llama 3. Here we are in the prototype of GeoForge, and this is really a scratch of what will be possible to do with time, with language models, and geospatial data. So we have a map interface here on the left. We have retractable menus one for chat and one for the session. With time, we'll have more settings such as, a home button, a button for settings and checking out different map features. So here, what I'll really start to do is I'll start putting in some text values for the town of Geneva. Here we're in Switzerland, so we're going to look at Geneva data. Currently, the datasets that are integrated within this app are open datasets. With time, of course, we do want to integrate datasets that are more licensable, things you can actually buy and then license it to other folks. So the idea here is that we write a message in the text interface, such as generate me a map of the country of Ghana, for example, and then the request will be processed in our backend, and we can then find our map of the country of Ghana here. We can change settings top right and see if we can download the data as well. So the data has been downloaded, and now we can open it on QGIS very quickly. I have my file that I downloaded. I can just drag and drop, and I can find it in QGIS. Let's come back to our platform here, and now that we have the country, we're going to look into the city. So generate me the schools in Accra, Ghana, which I believe is the largest city of Ghana. Let's take a look. So this is going to go through the OpenStreetMap API and go grab some of the schools. We can have a deeper look if we click in each one of them. So here we have a school, and we have one here, and of course we have the OpenStreetMap metadata associated to that school, which is really fun. If we put in railways now, so now that we have schools, I want to see railways. So here, I hope it's going to recognize that before we asked for schools in the same area. So if we're right, it should show the railway. So let's put a different color here. And as we can see, we have a bunch of rail lines, and if we zoom in here, we do see that those overalign the actual railways. Now we can ask for train station. Now generate the train stations. Again, it's always remembering that it asked for that specific area. So it's going back to here. We have our train station. Maybe we can look into some raster imagery now. So generate the satellite imagery of Accra, Ghana during October 2023, for example. So here it's going to, by default, select something that's optical. So usually it's going to go for Sentinel. We do also have Landsat in it. Let's see. Oh, yes, we do have something that was generated. And as you can see, we have a optical imagery of Sentinel-2 from October in Ghana. So you know what? Let's download all the data that we generated, and let's put it on OpenStreetMap. I'm back in QGIS, and now I'm just going to drag and drop most of those files, and we have the data that we generated, which is really cool to have the data that was generated by text. We find it instantly from a drag and drop in OpenStreetMap, in QGIS, sorry. I would like to thank you for your attention, and I'm very excited to see you on our website or on our LinkedIn.